Good morning, everyone, or afternoon, depending on when you're watching. So, just looking at the page here, what we've been doing so far. Okay, we're working today. We'll be um, looking at the unit circle. So, here you can see that I put up a unit circle printout. So, I'm just going to click on this, and this is what we're going to derive today. So, here we have uh, this sideways, but as you go around the circle, uh, okay, the 90 degrees should be up here. It's in landscape form, but this is what we're going to derive today. All the special angles, all the 30, 60, 90 angles as in each quadrant, and how what their exact values will be around the unit circle. So we're going to look at that today. This is a printout for your reference. You don't have to memorize it. You'll print this out and use it throughout the unit and the next unit in our trigonometry, area. So that's up on the page there. So we'll go back again here, just right there. And then today's videos will probably below it here. I haven't posted them yet as I'm just making it this morning here. Okay, so let's shrink this out of our way and get this out of our way. And we'll open up our Blackboard and start up today. Okay, so today we'll see how far we get. I don't know if we'll probably bother even doing practice today. We'll see how that goes. Yesterday we looked at using the unit circle formula, okay, and that was x squared plus y squared equals 1. And a unit circle, again, the definition of that was that a unit circle is a circle that has its center at the origin and a length for its radius of 1. Okay, and that's what we did yesterday. And we looked at two types of questions yesterday: how to prove that the point is on the unit circle, and how to find an x or y if one of those is missing. Today we're going to look at what the unit circle looks like. So let's get going on that, and we'll try to keep this video fairly short. See how long it takes us. So today we're looking at day 3, I think. I can't remember. Let's take a look back here. Day 3 today in Unit 1, and it's September 8th. Okay, and what we're going to look at, this is Pre-Cal 30. And what we're going to look at today, stupid, I didn't quite move it over enough, but close enough to being there. We'll move that over a little bit. And what we're going to look at today is we're going to look at the angles within angles within the unit circle. And we're looking still in section 4.2, the second part of it. First part of it we did yesterday. Okay, so we take a look at the unit circle. So let me draw an axis first with the quadrants, x and y axes. Okay, and then we're going to put a nice big circle in there. I'm going to move this up just a little bit more. Okay, and we'll put a nice big circle in there. Should I use a different color? I think maybe. Let's go with green. Okay, and so there we have making this a little bit longer so it goes all the way down. Okay, there we have our unit circle that we're going to use. So now we have that origin there. So if we label this up a little bit, okay, so this is 0, 0 here, and the radius is 1. So this point here, right on the edge of the unit circle right here, it's going to be 1x length because it's the radius of 1 all the way out here, but no y because it's not lifted up. So this is 1 and 0. Okay, if we rotate all the way around, this top one is going to end up being 0 and 1. These are right on the edge of the quadrants. Okay, and if we go back here, this, of course, the x is backwards. It's -1 and 0. And then down here, it is going to be, okay, it's going to have no x, but it's going downwards, so it's going to have a -1 for y. Right on that quadrant, right there. Okay, so the first one we're going to look at is we're going to look at the 45-degree placement. So we're going to look at 45 degrees here, then we're going to look at a 45-degree reference angle in the second quadrant, and the third quadrant and the fourth quadrant. So we can just draw the lines in there at 45 degrees. So I'm going to approximate because I don't know exactly. So it'll be about halfway. So that would be the first one there. And then approximate 45 here somewhere. Okay. Now, of course, you have this printed out for you on the printout, but we're just going to derive it. So if this is 45 here within the first quadrant, we'll look in the first quadrant here. Okay, now you have to remember that that's 45 degrees. Now, if we look at that in terms of radians, well, 180 degrees is pi radians. Okay, so 45 goes into 180 4 times. So it's a fourth of 180. So then it would be pi over 4 radians. It would be 45 degrees. Or if we look at it in radians, pi over 4 radians. Okay, radians. So you can use both unit measures, 45 degrees or pi over 4 radians. Now, if we look at the projections that this has, okay, so we'll make little arrows in here. So it goes out here for our x, okay, and it goes up for our y. We'll use a different color. Okay, that's 90 degrees. That's a little bit, went a little too far with the x. I'm going to back it off a little. Okay, so let's do that again here. Okay, so this will be our x projection there. Maybe right there. Then our y. So that is what it would look like. So this point up here, okay, and this is our x in purple. And our y down here. Now we know the relationship here. 45 degrees, this is, okay, 1, 1, and root 2. Or sorry, pardon me, you got that wrong. This is 1 here, but we know that this would be 1, 1, and root 2 in our relationship. So we have to do a little bit of a ratio type thing. We know that this is 1 because that's the definition of a unit circle. Okay, so if we're thinking to ourselves, well, if this is 1, we know that the unit circle is x squared plus y squared equals 1. because that would be that. So what is x and y going to be? Well, we know that x and y are going to be the same length for the 45-degree triangle. Or if we look at the ratio of a 45-degree triangle, special triangle, we know that, okay? So if we're thinking to ourselves, well, okay, if x and y are equal, one way to put this, whoops, there's a fly bugging me there. One way we can put it is we can say, okay, well, we can say, well, if this is x and x is equal to y, then we could say, well, it's the same thing as saying 2x is there. So x squared plus x squared could equal 1. So 2x squareds could equal 1. X equals y in the 45-45 triangle. So therefore, we can say that x squared, we'll go with 2x squared equals 1. So x squared is equal to 1 over 2, or x is equal to 1 over root 2. Okay, square root of 1 is 1, square root of 2 is that. Well, that's not what we want. We want it to be rationalized. So if we, there's a fly bugging me here. So if we rationalize that, x would equal root 2 over 2. Okay, multiply both by root 2 over 2 to rationalize. Okay, so that tells me that the x point here and the y point there is root 2 over 2 and root 2 over 2. Because x and y are equal in the 45-45 triangle. Okay, well, that's good to know that point. So now we have a 45-degree reference angle here. So this point is going to be a little bit different. The x can't be positive because it's not going to the right, it's going to the left. So it just changes to have negative root 2 over 2 and root 2 over 2 for y. Okay. And as we go around, we go down to this one, it's going to have both negatives. It has a negative x because it's going left and a negative y because it's going down in the third quadrant. Remember, this is quad 1, quad 2, quad 3, and quad 4. Okay, so then here we have negative on both of those root 2's for x and y. And then this one's going to have a positive x and a negative y. Same reference angle for all of those 45 degrees. Okay, so now this would actually not be 45 degrees as a standard angle, just a 45-degree reference angle. So 90 and 45 is 135 degrees. Okay, but a reference angle of 45. So how much is 135 in terms of radians? Well, radians up here is pi over 2 for 90 degrees plus another pi over 4. So this is 3/4 pi radians. Okay, and this one here, again, if we go all the way around, this is 180 degrees, and we want to add another 45. So that's 225 degrees right here. Okay, and if we're doing that in radians, okay, well, this is pi plus another quarter, that's 5 pi over 4 radians. And then finally, this is our last one here. If we go all the way around, this is 270 plus another 45. That's 315 degrees. Okay, and that can also be written in radians. Okay, if this is 2 pi, we go back 45, or take a 45 away, that's 7 pi over 4 radians. Okay. And that is basically all the 45 angles. 45, 90. That's all the multiples of 45. Now we can do all the multiples of 30 and all the multiples of 60 as well. We have 90 in there already, but I'm not going to derive all of those. If we do, basically, if we do the 30, 60, 90 degree triangles, it would be the same process with a different angle, except we'd have to use a different method to get the x and y. We'd have to use a ratio because x and y are not the same like they are in 45. It's not 1, 1, and 2. We'd have to use the ratios of it. But I never get you to derive those because if we go back to our formula sheet here or our original page here on Moodle, okay, and we open up this unit circle handout, even though it's sideways, so 90 degrees is here, I've got it sideways. So there's the 30 degrees is root 3 over 2 and a half. 60 degrees is a half and root 3 over 2. Okay, so those are the relationships in there. Okay, and then that multiple follows it all the way around. Okay, and each of the degrees are written in there and each of the radians is written right beside it. So this is, you can use this as reference. Okay, and now what they say up here in the corner here is you notice that the x point is equal to cosine and the y point is equal to sine, and I'm going to show you why here in a minute. Okay, so you can use this unit circle and this reference. Okay, we just derived the 45 ones, multiples of 45, but there's multiples of 30 and there's multiples of 60 in there as well, and they're all written on here, and then it gives you all the coordinates on the unit circle right around it like that. So you can use that as reference. So let's go back to our notes here. Okay, now one thing I did say is, well, why is it sine and cosine? Why is it the same as if cosine theta and sine theta? Why is that? Why are those points the same? The x is equal to that. Well, I'll show you, because we are on our unit circle. We know that x, for our case here, and y and r. We're going to call this r for radius and x and y there. So we know that, I won't start with the x there, sorry. Let's start with sine. Sine we know is opposite over hypotenuse. So the opposite side is y and the hypotenuse is 1. Y over 1, which equals y. So that's why sine theta equals the y point. Okay, that's why it's second here. It's the y point. Cosine theta is equal to adjacent over hypotenuse. In our case, if we're looking at the 45, the adjacent side's x, and the hypotenuse is r, or 1. X over 1, which equals x. So that's why the x point is cosine and the y point is sine in the unit circle. So that's helpful. So if I ask you, what's the sine of 45? It's root 2 over 2. What's the cosine of 45? Root 2 over 2. Okay? It's right in the unit circle. Okay, so that's the unit circle. You can use the rest of the unit circle printout, so you can probably print that out sometime and keep it for reference to solve some pretty simple questions. Now, what's a full revolution here in a circle? Well, it's 360 degrees or 2 pi. This is pi over here. This is over here. This is 90 degrees is up here and 270 is down here. Okay, So we can actually put those degrees in there as well, just so you don't get confused. Okay, this is 0 on both the radian and degree. This is 90 degrees, or pi over 2, half of 180. Okay, this is 180 degrees, or pi radians. This is 270 degrees, or 3 pi over 2 radians. Okay, and that's written on your sheet as well. So you don't have to like memorize anything. You can just look at that sheet, but you need to print that out because you're going to use it quite often. Okay, so let's look at that gives us, let's see how much time we've used up here. Okay, so we've used up good 15, 20 minutes there, 15 minutes. Let's look at a couple different questions here that come up with this section using the unit circle. Okay, so we'll take a look at a couple sample problems. I'll do that on the next page. Okay, don't worry about deriving the 30 and 60 degree ones, just use this sheet for information. Okay, so let's take a look at a couple of samples here. So in this section, we'll title this example problems within the unit circle. Okay, so it's not really difficult stuff. It's a lot of looking in the circle and stuff. Okay, so like we did yesterday, we did the first part of it. Is this point on the unit circle or not on the unit circle? So we did like questions 2 and 3 in this section. So now we're going to be looking at other, oh crap, I got to move that over. Sorry, guys. There we go. Let's move that over. There we go. All right, so we're going to look at a couple of different types of problems. So today is being Friday and all. It'll be a nice little short day for us in this class. Okay, so there's only 2 types of examples that we're going to look at particularly here. The first type is looking for a particular point on the unit circle. So example 1, type 1. Okay, and that would be, let's say, we'll call it determine the exact coordinates. So this one basically is like reading a chart or reading a map. So if I had it, for example, if I said, find the point for, they usually use P, and they give you the angle in brackets. So they might say, let's say 225 degrees. I don't have a degree sign, so I'll write it in there with a pen here. So put the degree sign in there. Remember, if they put a degree. So in that case, we simply look these up. So we would go back into our unit circle, look for 225 degrees right there. Okay, and it's negative root 2 over 2 and negative root 2 over 2. So our coordinate is equal to negative root 2 over 2 and negative root 2 over 2. Okay, so you're like, oh yeah, I can do that, no problem. Okay, so they'll throw in a little bit of tricky stuff there. They might wrap it around the circle twice. Okay, remember the circle is 360 degrees each time. So they might change it to radians. So they might do something like this. Let's do it 1 in radian. Pi, or the point equals, let's say they had a negative pi over 3. Okay, so let's go on to our unit circle. Okay, so pi over 3 is right here, 60 degrees, but it's negative, so we have to go negative 60 degrees. So negative 60 degrees, so if we're looking at that, or negative pi over 3 has to be removed, so we have to go down, so it has to go down to this one here. So another way to look at that is we're going down on the unit circle. So if I go back into my notes here, I'm looking at it as this would be the same as saying 2 pi subtract pi over 3, which would equal, okay, well 2 pi is 6 pi over 3. If we do it fraction-wise, right? 2 is 6 over 3 minus pi over 3, or 1 pi over 3. So that's equal to 5 pi over 3. So that's where we look on the unit circle. Or you could just simply go down 60 degrees or pi over 3 radians. So if we look at that on the circle, okay, right there, 300 degrees it would be, which makes sense, right? If you're subtracting 60 degrees from 360, or if you're subtracting pi over 3 from 2 pi radians, it's going to be 1/2 and negative root 3 over 2. Sorry about the side laying, but when you print it out, you'll be able to look at it straight. So this is 1/2 and negative root 3 over 2. So that's our coordinate. Okay, so that's the first type of question. Okay, and they might wrap it around there too. So they might say, we'll do one more. Let's say let me just set my pen. There we go. Let's say for the point. Okay, so let's wrap it around. Let's say it's let's go 480 degrees. Okay, so 480 degrees, if we take away one revolution, because it's wrapped around once, that's going to be 120. So it's one revolution plus 120. So it's gone around the unit circle once and come back. So we got to look at the 120 area. So if we go back to our unit circle, 120 degrees is right there. So it's negative 1/2 and root 3 over 2. Okay, right there. So if you think about it, we've gone around the circle and then there to get to 480 degrees. Okay, so that'd be negative 1/2 and root 3 over 2. Okay, so that's basically the first type of question. Those three, just finding points on the unit circle, just basically like reading a map. Okay. And then the other one they would do is the opposite of that. What is the sorry, what is the identify the angle if they give you the point? I guess there's three types of questions here if I'm thinking of it, because I forgot that you can go both find the angle and find the point, which it's kind of similar. So the next one we're going to look at here is given a point, finding the angle. And so from 0 to 360 degrees, find the angle for the point. Let's say the point is, let's go, because I got to use roots here. Let's go back to pen here. Stupid flies just flying around me. Okay, so let's say it will be negative 1/2 and negative root 3 over 2. Okay, so from 0 to 360, so we go to that negative, so we're looking for, whoops, I forgot already, negative 1/2 negative root 3 over 2. So negative 1/2 negative root 3 over 2 would be in the fourth quadrant, in the third quadrant because they're both negative. So looking in the third quadrant, negative 1/2 negative root 3 over 2 is this one here. So that's 240 degrees. Theta equals, so they would write it like this, point, and then they give you that. So theta, they might have a theta on it. Okay, and that would be 240 degrees. Now, if it's in pies and stuff, then you'd have to write it as radians. Okay, so they might say a little bit with that as well. They might say for point, let's go negative root 3 over 2 and 1/2. Negative 1/2, let's go like that. Find one positive and one negative angle. Okay, from 0 to 360. Okay, so if they say that, you got to go on the unit circle and then you got to read the positive one and then figure out what the negative one would be. So if we do that, both negative root 3 over 2, so it's going to be in that third quadrant again. Negative root 3 over 2 and negative 1/2, that's 210 degrees positive. So we've got the first angle as theta would equal 210 degrees. Okay, and then the negative angle, if we go down to 210, so we got to go 360. So if you look at it here, better look at it while we're doing it. Okay, we've gone from here all the way around to there to get 210. So we've got to go from here all the way down to there. So that's 90 degrees. Okay, and this is a multiple of 30 here and 60 more. So 90 and 60 more, that's negative 150. Okay, another way to look at it is 360 minus that, 210. Okay, so we can say, or theta equals 360 minus 210, which equals negative 150. I guess I did it wrong. It's 210 minus 360 because it's a negative angle. We're going down. Okay, so let's write that properly. So let me fix that up. Okay, you can also visually see that as you're going down. So it's really, if you want the negative angle, you got to write the bigger number second. So let's do that correctly. So it's really the 210 subtracting a rotation to give us negative 150. Okay, degrees. And that's the second type of one. Okay, and that's basically, looking through the practice problems here, there are some word problems that basically you can look at. Let's see here. And that's pretty much it, I think, that we're looking at here. Okay, sometimes they have you to find not, I guess we can say sometimes you have not perfect angles as well. So let's take a look at one of those just in case. Make sure I cover everything here today. Let's see what time we got. Well, actually, maybe we'll stop there and we'll look at that stuff in the next day, determining new angles, because we spent a good few minutes on that. Okay, so I'm going to stop here. Fairly simple, so let's just review what we looked at this morning. Okay, the unit circle, we did multiples of 45. Keep in mind that there's multiples of 30 and multiples of 60 degrees there. Okay, sorry about that. And that's going to be that printout. So print that unit circle out that's in the Moodle page and use that for reference. Okay, and then we just looked at the two types of questions. Determining a coordinate, okay, given the angle. Okay, so that could be in degrees, or it could be in radians, or it could be negative or positive. It might even be wrapped around more than once, and then you just use the unit circle. Given a point, finding the angle, okay, you get the point, find the angle between 0 and 360. Sometimes they'll say between 0 and 720, so there'll be two answers, right? So you have to add 360 onto it. Okay, and in this case, they wanted one positive and one negative angle, so you got to get the positive angle and then figure out what the negative angle would be by looking at the unit circle. Okay, then there are some other types of questions that don't have these perfect multiples using special triangles, but we'll save that for when we get into section 4.3 when we have to use our calculators, and then we'll have to be very careful to make sure we're using degrees and radians. So we'll stop there for a short day. I'll leave you a few practice questions. Okay, it's the same page that we were looking at last day, on page 187 this time. Okay, and you can try just looking at number 4. Doesn't have to do all of it, but do some of number 4. And number 5, which are the two types of questions that we looked at today in our examples. And you can look at number 6, which is also there. And the rest of the stuff will kind of blend into the next section that we're doing. So we will look at that a little closer on when we get back at it on Monday. Not too sure yet exactly if we're going to have a skip day here where I can get ahead of you guys a little bit. But right now I'm doing fine because I haven't been too busy with volleyball. So this is working out good. I come earlier in the morning and get this done. So, okay, so a little bit of a short day. I'm going to stop there. Have a good weekend if it's the weekend for you, or depending on what day you're on. For me, it's the weekend coming up, so have a good weekend. If you do have any questions, I think the only 4 of you are taking it online. That will be Cody, Braden, Shade, and Taylor. So if you guys have any questions at all, make sure you pop me an email. I did send out yesterday a Hangouts request to everybody. Braden and I had yours from last year, I think, so that you can use that. If you have a question, get me on my phone and I'll answer. Busy right now, I'll get to you in a couple minutes, or yes, what do you need? And I can answer you that way. And usually I'll just make a little video and send it to your email. So you do have contact with me through Hangouts there, and you know that you can get me anyway. So enjoy the weekend. I'm going to stop there and try at least some questions in 4 and 5 and 6. It doesn't take long to read the unit circle. Print that unit circle out, laminate it if you want, hole punch it, stick it in your book. You're going to need it for the next 2 sections, or lots of sections at least. All right? See you. Oops, not that one. That one. So print this out and use it.